Welcome to e-Podasala lecture series in computer science. Last module we discussed about the analysis of algorithms. From this module onwards we are going to concentrate on algorithm design technique. One of the primitive design technique is brute force strategy. So in this module we are going to concentrate on this particular primitive algorithm design technique. The objectives of this particular module is to understand the concept of brute force technique. We are going to discuss about some of the examples that are coming under this particular category. We are going to discuss about the search problem. As part of that, we are going to concentrate on linear search algorithm, one of the primitive algorithm that is available as part of search techniques. We are also going to discuss about the sorting problem. We are going to discuss about the advantages and disadvantages of bubble sort and selection sort algorithms. What is a brute force approach? This is a very straightforward approach, usually based on the problem statement and the definition of concepts involved as part of the problem statement. This is one of the most primitive algorithm design technique where we are not going to use any special strategy for solving the problem. Instead, we are going to depend on certain crude techniques that are available to solve these sort of problems. So for this we are going to use the problem statement and the various concepts that are involved as part of this problem statement. This is one example of a brute force approach. Suppose let us assume that we want to find the value of the exponential function a power n, where a is a non-zero number and n is a non-negative integer. There are lots of algorithms available to solve this problem, but in brute force we are not going to bother about any special technique, but instead we are going to multiply a straightforwardly n times to get this a power n. This sort of approach is what we are calling as the brute force approach. What are the advantages of this brute force approach? If it is not very effective, then why should we study about all the things? These are the various strengths of the brute force technique. Number one is it is widely applicable. It is not limited to any one particular domain of problem, but instead it is applicable to almost all sorts of problems. Second reason is simplicity, because this is what naturally and intuitively we are approaching the problems, and this also yields some reasonable algorithms for some important problems like sorting and all. And finally, the most important point is it provides some sort of algorithms that can be used for comparisons. In other words, if we are using some special design technique and use the technique for designing algorithms to check its effectiveness, we can compare that with algorithms that are designed using the brute force approach. These are the positive points. Then what is the negative point? The negative point is brute force technique rarely yields efficient algorithms. Normally the algorithms are tend to be very ineffective and most crude way of solving the problems. Second reason is this technique is not using any constructive or creative idea for solving these sort of problems. So solutions are not very innovative as part of this particular technique. Fine. So, we will take one problem as example of this brute force approach. So, our methodology is going to be like this. We are going to take a problem. So, I am going to give you the formal definition of the problem. Then we will solve this problem using brute force technique, and after that we will start writing an algorithm for that, both informally as well as formally, and finally we will analyze these algorithms so that we can use these results later on for comparison purposes. So, first problem we are going to take is called the linear search. It is also known as sequential search. So, the problem is like this. We are given a list or array, and these list or array are going to contain lots of orderable elements, and we are also given a target item, and we have to check whether the item is found in the entire list or not. This is what the statement of this particular problem. So, the informal approach is very simple. I have to start traversing the list or array until the desired element is found or the collection is exhausted. So, this sort of problem is what we are calling as search problems. In algorithm studies, we will encounter search in a number of applications. So, we can compare this with our day-to-day applications. For example, I can search the attendance list to check whether a person or student name is present or not. Similarly, we can also search for a particular book in a rack or so. So, search problem is one of the most important problem we encounter in algorithm study. So, lots of interesting algorithms are available. So, we are going to study about one of the most primitive algorithm that is available, that is called the linear search algorithms. So, this is what the problem looks like. So, you can see very well we are given a list. The programmable implementation of list is what we are calling as array. So, therefore, we do not make much distinction between the list and array. So, this is the list we are given. So, the problem is I have to check whether the value 8 is present or not. Suppose if this problem is given to us, so how normally we will do is we will go to the start of the list, then we will compare 8 with 10 to check whether the 8 is present or not. If so, we are going to declare that the item is found, otherwise we will just proceed to compare the next element of the list. This is how it goes. So, you can see very well I am comparing 8 with 10. So, my target is not present. So, I am just progressing to check the next element of the list. Again, target is not obtained. So, I am progressing fine, my target element is present. So, let us take one more example. Again, you consider this list. So, you can see very well the elements of this list are like this, and I am going to check whether the element 23 is present or not. Fine. So, we will progress like this. Target is not present. So, again it is not present. I will just go on to check the next item. Fine, 23 is not available. So, I will progress further. So, now we have come to the end of the list. Therefore, we will say that 23 is not found. So, this kind of algorithm is what we are calling as the sequential search algorithm or linear search algorithm. So, let us try to conceptualize all these ideas into some sort of an algorithm. So, this algorithm I am writing like this. So, algorithm search. So, the input of this algorithm is going to be an array or list. So, let me take the array whose contents range from index 0 to n minus 1, and I am given a target item. So, this is the input. So, the output, as I said earlier, we have to say we have to return the index if the target is present, otherwise we have to return -1 as part of the process. So, this is what begin. So, you can see very well the index is initialized as 0. So, I am starting a loop, and as part of this loop I am checking whether the item target is present in the array or not. If it is not so, then I am incrementing the index. Suppose if the item is present, then I am going to come out of this particular loop, and then I will check whether the index is less than n. If that is the case, I am going to return the index or the position where the target element is present. Otherwise, I am going to return the value that is -1. That is, if the item is not present in the array, then -1 will be returned. This is what the conceptualization of our initial ideas. Fine. Suppose if this algorithm is given, how we are going to analyze? Just recollect in the module where we discussed about the iterative algorithms. I was telling you that the way to analyze this algorithm is we have to identify a basic operation, and then we have to take a count of how many times the operations are carried out. Fine. In this particular algorithm, the input size is going to be n. So, n elements are present, and I have to choose the basic operation, and the basic operation that is very natural for this algorithm is comparisons. So, where we are trying to compare the target element with every member of the array. Suppose if we take the basic operation like this, then as I said earlier, we have to find how many times this comparison is carried out. So, we have scenarios, best case, worst case, and average case. Let us try to analyze all the things. Best case is a scenario which is considered to be the best possible scenario for the given problem. Suppose if the target element is present as the first element of the array, then in one comparison we can find the answer. In that case, the comparison is going to be 1. What about the worst case? The worst case scenario is what we are trying to find is present as the last element of that particular array. In that case, at least n comparison needs to be done. Fine. What about the average case? As I said earlier, the worst and best case is not accurately reflecting the scenario. On the other hand, we have to find the average case. Finding the average case is not a easy task, because we have to do lot of homework. We have to consider all possible configurations, then we have to introduce the probability here, and then we have to consider the scenario where we can get the average number of comparisons. So, you can see for this problem, the average cost is computed as the cost of success multiplied by the probability of success plus cost of failure multiplied by the probability of failures. Fine. The target can be the first element, it can be the second element, or it can be the ith element, or it can be the nth element. So, you can see very well the cost of success is 1 plus 2 up to n, and the probability of success is going to be p by n. In other words, the target is equally likely, and the cost of failure is n into probability of failure is 1 minus p. Suppose if we simplify everything, you can see very well 1 plus 2 plus n is nothing but the Gauss formula, that is n into n plus 1 by 2 multiplied by p by n plus n into 1 minus p. If we simplify everything, then we are getting this. So, if probability equal to 0, that means if the search fails, you can see very well this expression is reduces to n, and if search is succeeding, then we can see very well it comes down to n plus 1 by 2, approximately n by 2, that is nothing but theta of n square. In short, the best case analysis is order of 1, the worst case scenario is order of n, and the average case scenario is going to be order of n. Since it can be represented using O, big O in all the situations, we can easily represent that as theta of n. Okay. So, this is what the algorithm is all about. Next, we will go to the sorting problem. So, in sorting problem, find the input is going to be a set of numbers a1, a2 up to an, and the output is going to be the sorted sequence, that is we are going to sort this either in the ascending order or in the descending order. Fine. Sorting problem is also one of the most important problem which we encounter in algorithm study. So, you can see very well there are many situations where I have to find whether the keys are distinct. Sometimes I may want to know the count of those keys. For those sort of situations, sorting is absolutely necessary. Fine, these are some of the terminologies that normally we will use. One is called internal sort. In internal sort, all the numbers needs to be maintained as part of computer's main memory. Then external sort. So, here the data may be present in the external device also, and in place sort. So, the amount of extra storage to required to sort remains constant with the input size. And similarly, the stable sort is one that preserves the relative order of the records if the keys happen to be equal. These are the terminologies that are normally associated with sorting. So, many people have solved this sorting problem in multiple ways. In brute force technique, we are going to discuss two important techniques. One is called the bubble sort and selection sort, and again we are going to analyze, and we are going to keep this as the base benchmark for comparison purposes. I will start with bubble sort because this is historically the oldest sort that is available. The logic of bubble sort is very simple. Simply I will just walk down the list and I will compare the adjacent elements, and I will swap them if necessary if they are in the wrong order, and I will keep on proceeding this till the entire list is sorted. So, bubble sort is one of the most primitive sort that we have. Fine. Informally, I can conceptualize that idea into an algorithm like this. So, I am just comparing each element with the neighbor to the right, and I am checking whether the order, that is whether the ascending order or descending order is preserved. If they are out of order, then I am going to swap them. So, this puts the largest element at the very end. So, that means in the subsequent phases I do not have to bother about that particular thing, and I can carry out with the exception of the sorted elements. So, this process is going to be repeated, and I will continue this process until there are no sorted elements that are available as part of the list. So, this is what the bubble sort is all about. So, let us try to illustrate that by means of a simple example. Let us consider these elements. So, I just want to sort this. So, you can see very well this number 6 and 1 is not in the correct order. So, therefore, I am just exchanging. So, I am getting the list 1, 6, 8, 5, 4 now. So, again you can see very well this 8 and 5 is not in the order. So, I am just exchanging this. So, again I am comparing 8 and 4, it is not in the proper order, therefore, I am just exchanging. So, now you can see very well as at the end of this particular phase we can see that the largest element has bubbled into the last element of this array. So, that means in the subsequent phase this particular position need not have to be disturbed, because the correct element has bubbled into this largest position. So, now in the next phase I will start with this. So, again I will check whether the numbers are in the correct order. So, if the order is not proper, then I am going to exchange these two. So, again you can see very well this is not in the order, I am exchanging. Now, I can see very well the 6 has bubbled into its correct positions. So, again I will start with this. In the next phase 4 and 5 is 1 and 5 is in the proper order, but 4 and 5 is not in the proper order, therefore, I am exchanging this. So, now I am left with this. You can see very well now I have to compare only 1 and 4. So, that means it is in the proper order, therefore, I can say that these elements are in the sorted order. So, this is the kind of idea we are going to follow as part of this. Fine, quickly we can see what is that algorithm is all about. So, now you can see very well this is the input array whose elements range from 0 to n minus 1. So, now you can see very well this is the passes 0 to n minus 1. So, I am starting the loop, inside I am making a comparison, and if this case is not there, I am exchanging. So, you can see this is how the analysis is going to be. The number of input element is going to be n, and I am going to use the base operation of comparison of a j and a j plus 1. So, now the question is how many times this comparison is carried out. I can proceed further. Now, you can see very well this is the loop which we have started for I, starting from what you say 0 to n minus 2, and this is the inner loop which we have started from j equal to 0 to n minus 2 minus I. So, inside that we are going to make a comparisons. So, therefore, it is going to be 1. So, now you can see very well you can simplify this, it will become something like n minus 2 minus I minus 0 plus 1. So, after simplification it becomes n minus 1 minus I. So, now you can see very well this starts from j plus 1 to n minus 2. So, if you substitute this you can see very well, you can see this is simplified to n into n minus 1 by 2. Therefore, you can see very well the complexity of this bubble sort is going to be theta of what you say n square. This is what the complexity. In other words, the best case, worst case, average case, no matter how the input is, we have to carry out this comparison. Therefore, you can see very well the complexity of this bubble sort coming down to theta of n square. This is what the bubble sort is all about. The last sort that comes as part of this brute force technique is selection sort. Again, the idea is very simple. We have to find the smallest element, and then we have to exchange that with the first position, and similarly find the smallest element in the remaining list and exchange that with the second position, and keep on continuing like this until this array is sorted. So, instead of smallest element we can go for the largest element also. No matter what we do, ultimately we are interested in generating some sort of a sorted sequence. So, this is what the informal algorithm is going to be. Given an array of length n, so we can search the element 0 to n minus 1, and then we are going to find the smallest one. We are going to swap that with the location 0. So, that means 0 is sorted now. So, therefore, for the next pass I will start from 1 to n minus 1, and I will find the next smallest element. I will keep on doing things like this, and I will continue till the entire thing is sorted. So, this is how the selection sort looks like. Fine, I have to find the smallest element. Let us check 6, 1, 8, 5, 4. The smallest one is 1. Therefore, you can see very well 1 is assigned to a position 0th position where it is the smallest one. So, in the subsequent pass, fine, I do not have to bother about this, I have to bother only about this particular list. So, 6, 8, 5, 4, the minimum is 4. So, you can see very well in the next stage this 4 is swapped with the next element of the list. Now, I have to bother about only 8, 5, 6. Fine, let us find the smallest one. 6 is the smallest, 5 is the smallest element, therefore, it goes here. So, similarly 8 and 6, the smallest one is 6. Again you can see very well 6 is put into this position. This is the last element, therefore, we can say that the list is sorted 1. Find the algorithm, we can conceptualize everything into a formal algorithm. This is the algorithm name, this is a list. So, the output we have to generate in the sorted order. So, I am starting a loop for the passes. So, I am just taking the index I as the smallest one, then I am starting the loop. I keep on finding the smallest one, and the smallest one is exchanged with the a of j. So, in other words, I am just finding the smallest element, and as the numerical example said, we keep on swapping that till we get an array that is in the sorted order. Fine. What is the analysis? The input size is n. Again, the basic operation is comparison. We have to find how many times it happens. Fine. So, this is what it is. So, this is the expression I am getting. So, if I simplify everything, you can come to a conclusion that this comes to theta of n square. In short, this is the summary. So, brute force guarantee solution, but it is inefficient because this is the brutal way of solving the problem. So, lots of examples are there. We discussed about 3 examples. Linear search performs searching in theta of n time, bubble sort performs sorting in theta of n square time, and selection sort performs sorting in theta of n square time. So, these are the various references. So, in this module we discussed about some of the examples of brute force technique, and in the next module also we will continue to examine some of the computational geometrical problems that are coming under the brute force technique. Thank you very much.